All right, let's talk about SOHCAHTOA. SOHCAHTOA only applies to right triangles. Okay, so let's say that we have this angle here on this side. Then what is this side relative to this angle? What is this side that I'm pointing here? Oh, not adjacent. Adjacent means next to. Huh? Opposite. Okay, so then we're going to say this is O. Okay, what about this side on the bottom? That is adjacent. Okay, what about this third side that's opposite of the right angle? Hypotenuse. Why is hypotenuse not adjacent? It is right next to, right? It is the hypotenuse. Hypotenuse can only be hypotenuse. Hypotenuse, by definition, are two. Do you know what makes a hypotenuse hypotenuse? Opposite of right angle, so that has to be hypotenuse. What's the second thing? The longest side. Okay, so opposite or the longest side. That has to be hypotenuse, cannot be anything else. Okay, so sine is what side over what side? So, SOHCAHTOA. Huh? Opposite over hypotenuse. So that's why you get a so. Sine, and then O is opposite, H is hypotenuse. How about cosine? Adjacent over hypotenuse, and then TOA, opposite over adjacent. Okay, this only works on right triangles. If we're going to go to non-right triangles, this will not work. All right. Okay, so let's solve a problem. Find the standard position angle. Standard position angle just means everything starts at 0. Determined by the point 8, -6. What are the values of the 6 trig functions? All right. First, you draw the point 8, -6. Where is 8, -6? Which quadrant? Fourth. Okay, so 8, -6. Oh, I'm sorry. 8, -6 is right here. Okay, what you do is you draw a straight line back to the origin, and you draw a straight line up to the x-axis so that you create a right triangle. All right, next. How long is this x side? 8. Because it tells me I have to go 8 here and then 6 down, right? So this is 8. What about this length? 6. Let's put +6 instead of -6. It is a length. Where are the 6 trig functions? So 6 trig function means sine, cosine, tangent, and all their reciprocal. Well, it depends on what angle we're talking about. We are always talking about the angle that's closest to the origin. Okay? Actually, in this case, let's put -6, so then we don't have to do extra work. All right, let's do sine first. Sine is what side over what side? Opposite over hypotenuse. So from this angle, opposite over, oh no, I don't have a hypotenuse. What should I do? Yes, Pythagorean theorem. A squared plus B squared equals C squared. So we gotta go and find the hypotenuse using right triangle. Or do you guys know, do you have this memorized? It's a very special right triangle. 10. It's the 3, 4, 5 triangle, but doubled. Okay, 3, 4, 5 is a special right triangle. You have to just memorize that. Oh, okay, opposites over hypotenuse. And then you just go ahead and find all the other ratios. Okay, I'm gonna have to change your homework again. Okay, it's like a battle game through chapter 14. Okay, so let's go to page 7. We didn't finish this problem yesterday, so let's just finish it for your notes. Okay, we got to this point where we had a triangle based on where our point is, which is 8, -6. We drew a right triangle where we connected a point back to the origin that became the hypotenuse, and we connected a point back to the x-axis, perpendicular to the x-axis, and that created a right angle. So we have a right triangle. And then we figure out two of the sides, 8 and -6, because of where that point is. And then the diagonal we can figure out by a squared plus b squared equals c squared. That gives us 10. Then, because the question says they want 6 trig functions, that is the sine, cosine, tangent, and all their reciprocals, we just ask ourselves, what are the ratios? Okay, so we got to sine. Sine is what side over what side? Opposite over hypotenuse. Therefore, we look, so the angle has to be the one that's closest to the origin, okay? There are two angles, so please do not pick the wrong one. You would be writing the opposite ratio from everybody. Okay, so the angle has to be the one that's closest to the origin, okay? The one that's turning around in here, right? Because that's where the circle is. Okay, so opposite of this angle is -6. Hypotenuse is 10, so this ratio is -6 over 10, or we can reduce it. It becomes -3 over 5. All right, cosine is the same. Cosine is what side over what side? Look at your SOHCAHTOA.
Adjacent over hypotenuse.
Yeah, adjacent over hypotenuse. So adjacent, so next to the angle is 8. Hypotenuse is 10, so 8 over 10. Okay, which is 4 over 5. All right, someone besides that area. Tangent. Tangent is what side over what side? SOHCAHTOA. Yeah.
Opposite over adjacent?
Yep, opposite over adjacent. So this is -6 over 8, so that is -3 over 4. All right, cosecant. Let's go to cosecant. Cosecant, if you recall, it is 1 over sine, right? 1 over sine. That means 1 over this ratio. But it is also just a reciprocal. So basically what we can do is just flip that fraction. So this is just going to be -5 over 3. Okay, so just flip it. Yeah? So we always just flip it. And then so secant is the same, 5 over 4. Cotangent is -4 over 3. So once you find 3, the other 3 are easy. Okay? Let's do another problem to practice. Okay, in a standard position angle, again, standard position means you're going to start at 0 and then you're going to turn. Okay, start at 0, you're going to turn. The point is -5, 12. What are the values of the 6 trig functions? Okay, so go ahead and try solving this. You're going to draw the point -5, 12. Draw a right triangle, figure out all the sides. If you need a calculator to figure out the hypotenuse, do that. Or else 5, 12, and something is a special right triangle again. And then figure out the 6 trig ratios. Okay, if you need help, let me know. All right, let me give you the numbers, the values, so you can double check. Okay, sine is 12 over 13. Cosine is -5 over 13. Please make sure you keep it negative, okay? 5 is going to the left, so that's negative. Tangent is -12 over 5. Cosecant is 13 over 12. Secant is -13 over 5. And cotangent is -5 over 12. Any questions? Okay, so when they have... Is Ryan okay? Yeah. If they give you a question where it says it's a standard position, they give you a point, and that point is somewhere on the 4 quadrant that has a positive and negative, you have to keep the negative. Okay, let's look at another question. This one is a little different. Make sure you read the wording. This one says, in ABC, C is a right angle. Okay, so it's just a normal triangle. It's not in space where there's 4 quadrants. You just have a right triangle, and then C is a right angle, so this one's C, and doesn't really matter where you put A and B. Sine A is 5/13. So that means A is here, some angle. Sine A is 5/13. Now let's kind of go back to kind of our detective work. Sine is what side over what side? Opposite over hypotenuse. So, right? So katoa, so SOH, so OH. That means O is 5, H is 13. Okay, so let's look at this triangle here. Sine A, so sine A, the angle A is here. Opposite of this is 5. Where would you put 5? Yeah, on the bottom. Okay, and then 13 is the hypotenuse, so gotta draw a right angle there. Hypotenuse is 13. There's only one place that can be hypotenuse. Now we have 2 of the 3 sides of the right triangle. The question is, what is cosine A? Cotangent A and sine B. The angle matters, so make sure you're reading the question correctly. All right, first question, what is cosine A? Cosine is what side over what side? Adjacent over hypotenuse. So cosine of A, so relative to this angle, we need adjacent over hypotenuse. Now, do I have adjacent? Not yet, okay? We can figure it out by Pythagorean theorem, or if you memorize your triangle, what's that last length there? 12, okay. So cosine A is going to be adjacent over hypotenuse, so 12/13. All right, cotangent A. Cotangent A is the reciprocal of tangent. Tangent is TOA, so then cotangent is what over what? What side over what side?
Adjacent over opposite.
Yeah, adjacent over opposite, because it's the opposite of tangent. Tangent is O over A, so then cotangent is A over O. All right, A over O is 12/5. Last one. This one's a little tricky. Sine B. Not A, B. So you have to look from B and say, what is opposite over hypotenuse of B? Okay, so what is opposite of B? 12, okay? Not 5 anymore. We don't keep a label on here and just call it O. It's opposite of whatever angle you want. Okay, so sine B, the opposite of B is 12. Okay, so this is 12/13. How are you guys? Let me know if you have any questions. Some of you are answering a lot. Some of you are like just kind of copying things down. Let me know if you have any questions. How do you know where's A? It doesn't really matter because the ratios are dependent on what was given. So you will always write it the same way. All right, so notice this problem and the previous problem look very different. One, you have a point in space, and then that means you have plus or minus. This one, there is no plus minus. Okay, so don't put a plus minus 12 on there when you're solving. It is a right triangle. When you draw a right triangle, it is just, you know, all the sides have to be positive in order to create a right triangle. Okay, all right. Oh, extra question. How do you figure out the measurement of A and B? I feel like you guys probably did it in geometry. You just forgot. Measurement. What's the measurement of A? Let's just do A. How do you figure out how big that angle is?
Since cos of A.
Cos? Cosine, okay. There you go. Good. All right. Sine A is 5/13, just like what we've been doing here, right? So then figure out what that angle is. Well, first of all, 5 over 13, is that in your unit circle? No. Okay, so then we have to use our calculator and then do the inverse. Okay, so use your calculator, and let's just keep it in degrees this time. Let's keep this in degrees. Because usually in a triangle, we never really talk about radian triangles. Just talk about 30 degrees, 60 degrees, 75. So let me know what answer you get in degrees. Huh? 23.6? 2.6. No, you have to be in degrees. Oh, I'm sorry, 22.6. 22.6. Okay. Now, are there two angles? Okay, talk to your partner. Are there two angles that you're supposed to find? Gotta reason it out. Are there two angles? Because when we're solving these, there are always two angles. So are there two angles you're supposed to find? Okay, let's vote. How many people think there is only one angle? How many people think there are two angles? Ooh, people are not voting. Let's try again. 10 more seconds. Talk to your partner. You can talk to Aaron today. Eunice is too shy. No. All right, let's vote again. One angle, raise your hand. Two angles, raise your hand. Ooh, one angle. Why? It is a right triangle, right? In a specific right triangle, there is only one possible angle. Does that make sense? You cannot have two angles. And also, if you try to find the other angle, it will always be negative or a very big angle that's more than 180 degrees, and it won't make any sense. So there's only one angle. And so when you see a real life object, there's only whatever the real life object should have. Okay, so only one angle. All right. Practice. Triangle DEF. D is the right angle. Tangent E is 3 over 4. What are sine E and secant F? Okay, let me know when you're done. Sine E is 3 over 5. Secant F is 5 over 3. Okay, make sure you're reading the angle correctly, whether they want E or F. All right, let's skip the word problems and then let's go to a problem. I feel like you've seen this in geometry. These ones down here. Find each length. All right, so there's a right angle here. All right, so we have two things that's known, one thing that's unknown. So we have an angle, a hypotenuse in this case, and then we want a side. So what you want to do is you're going to stand at this angle and say, what do these two sides, what trig ratio do these two sides make if this is the angle here? If you're standing at 37 degrees and you're looking at x and 10, what ratio would they make? What kind of trig ratio? Sine? Okay, yes, opposite and hypotenuse. So sine 37 degrees is equal to opposite over hypotenuse. Okay, so you always stand at the angle and you ask these two given information, what kind of ratio are they making, so then I can solve this. Tom, are you awake? Oh, okay. All right, so how do you solve for x? No, just multiply by 10. Okay, and then just put that in your calculator. Now, it says 37 degrees, so make sure your calculator is in degrees mode, or else your answer will be entirely wrong. Hopefully, you'll realize that the number doesn't make much sense with your triangle, but sometimes it's very close, so double check. 10 sine 37 degrees. Okay, what's your number? 6.02. All right, let's try another one. Number 2. Let's have you guys solve it. Let me know when you're done. So try to remember this in the future. Okay, so tangent 14 degrees is 3 over x. Do not just divide by 3 and then say like that x is there. Not true. If you just do this, this is 1 over x. Okay, you divide it by 3. That x is still in the denominator, so it's still 1 over x. Okay, so rookie mistake. Don't make this mistake anymore. Okay, don't do that. If you are very confused with things like that you have to solve, always put a 1 underneath and then just do cross multiply. Okay? Cross multiply always works and then it will always help you get the right answer. But please don't make this mistake anymore. This is, yeah, gotta correct it before next year. All right, so you would get x tangent 14 degrees equals 3. So then x is equal to 3 over tangent 14 degrees. Okay, so if you are having trouble with this part, make sure you write every step out with cross multiply. The answer is 12.03. All right, let's really quickly do 14.4. This is an easy section. The formula is also very easy to remember. So let's take a look at this. This is not a right triangle. So can we use SOHCAHTOA? No. Okay, SOHCAHTOA only works on right triangles, so we cannot do an opposite over hypotenuse because there is no hypotenuse. So when we have to figure out the sides, what we want to do is this thing called the law of sines. I didn't write it here. Okay, so let me write it here. I forgot to write it here. Sorry. Law of sines. First of all, let's label our angles. Okay, we have 3 angles, A, B, C. What do you call the side that's opposite of A? Do you, did you guys, I think you guys learned this in geometry. Is A, right? Is it still the same big A or we write it differently? Small a. So opposite of A, we put little a. Okay, what's the side that's opposite of B? Little b. And then opposite of C is little c. Okay, so 3 sides and 3 angles. Consequently, basically the ratio of sine and its opposite side, so meaning something like the sine A over side A, that ratio is the same in the whole triangle. Okay, so sine angle A over its opposite side is the same as sine angle B over its opposite side. It's the same as sine C over opposite side, but I think I labeled this wrong. I'm sorry. This is law of sines. C over C. So yeah, get rid of the law triangle area. This is for law of sines. So sine A over A equals sine B over B equals sine C over C. Okay, so that ratio is consistent throughout the whole triangle. It works even on right triangles. You can always use it on any triangle. Okay. So let's try solving some problems. In triangle PQR, P is 39 degrees, Q is 32 degrees, and PQ is 40 centimeters. What is RQ? RQ is this one. Can we use SOHCAHTOA? No, there is no right angle anywhere. Okay, we have to use law of sines in this case. So do we know any ratio where we have the angle and its opposite side?
R.
Yeah, R and its opposite side is known, right? So we can say that sine R over its opposite side, let's call this little r, it's the same as sine 39 degrees over 40 centimeters. They want RQ. Sorry, RO. They want RO. So if we want RO, it would be easy if we just know its opposite angle. Do we know the opposite angle? Not right now, but we can find it really quickly, right? How? Adding to 180. Good job on your geometry. So triangle sum theorem says all the angles add up to 180. So we can figure out this angle P really quickly. Okay, so go ahead and figure out angle P. Okay, so what is angle P? Huh? 109? So we can say this is the same, that ratio sine 39 over its opposite side is the same as sine 109 over its opposite side, which is the side that we want. Okay, so let's call this x. This is what we want. So this is sine 109 degrees over x. Okay, so the proportion, the ratio of sine 39 over 40 is the same as sine 109 over the unknown. Okay, now it's just cross multiply again. Okay, so you want to set it up. So don't take shortcuts with your cross multiply. And okay, and then when you write it, sine 39 times x. We usually don't put sine 39 and then x because it's very confusing. Is x inside or is x outside? So we always write the variable outside. Because if you put x there, it's not clear, is it inside the sign or is it outside the sign? So don't do that. So 40 goes outside as well. Just kind of some math skills. Now what we're going to do is divide by sine 39. Make sure you put it in your calculator correctly if you are planning to write everything out at once. That means anything in the numerator has parentheses, anything in the denominator has parentheses, so that you don't accidentally do the wrong pandas. Okay, what is the answer for x? No. Is it 60.1? It is, then maybe I... Okay, 60.1. Okay, let's have you guys try one and then we call it a day. Triangle KLM. K is 120 degrees, M is 50 degrees, and ML is 35 yards. What is KL? Go ahead and figure this out. Let me know when you're done. Okay, the answer is about 30.96.